To geospatial technology and applications. The geospatial technology comprises of three major components: global positioning system, geographic information system, as well as remote sensing. This is already declared as one of the three mega technologies for the 21st century and promises to provide how to capitalize, utilize, and visualize spatial information for scientific research, commercial applications, as well as general usage. This is at the end of this technology, when we understand, we will come to know what is what, that is mapping the precise placement of physical features, that is of more of descriptive in nature, and also why, if, and so what. That means we are able to model the precipitative information available and provide a spatial relationship between them. So one is descriptive and another one is modeling. Both are part and parcel of this very important technology. This also has a convergence of several technologies together. That means geospatial technology is just not a one or two. It's a combination. It's a convergence of many technologies, including aerial survey data, high bandwidth, which is available today. We have GPS already mentioned, remote sensing, GIS, and also information communication technology, location-based services with many smartphones available today for easy access. So you are able to do location-based analysis as well as photogrammetry and total station applications. So with all that, we are trying to look for a solution, a turnkey solution for a given problem, without really knowing into all these technologies in depth. The geospatial technology is also giving a very big challenge or very interesting problems for the researchers. We have the data, which is coming from various platforms like LIDAR, we are having SARs, synthetic aperture radar, hyperspectral sensors, panchromatic, and many other remote sensing platforms. And we also have very good number of automated processing techniques available today. We have co-registration of many different dissimilar resolution sensors. We need to identify the targets as well as find out the detection of changes which had happened between the previous and now. And we also have the information fusion technologies, which is again very important, where when we have multi sources data available, how you can combine them and make them a very useful one, one product which will be a combination of all. Then we also have smart databases where we will be able to recover the information or retrieve the information with the very partial information available in hand. Then also there is a very important element of human and computer interface activities like visualization and machine learning also is there. So as you can see here, when you go from data to information and knowledge, the action really builds up, and that is the real challenge for all the researchers. And we have many important researches to be still to be completed or still to be done to make this whole technology a very important one for all solutions, all problems that we are facing today. And also the geospatial technology provides another interesting idea. That is, you have to think think globally. That means you have got all data sets available in hand. This is probably very much required for the policymakers as well as the decision makers, where they have all data available in hand in a global scale, but also they need to act in a locally what needs to be done. For example, land resources, how it is, although you are looking at a particular area, it is also being affected by the neighborhood information. So that is where we are saying that not only the specialized application, which is the ultimate objective, but also it requires local, regional, and global information as well. For example, when you want to monitor the vegetation or extract the features or change detection in the scenario like a flood monitoring and object recognition, in all this acting locally, though important, we also can do it in a global sense. Again, it's another important application. Next, human resources. It is the assets and facilities management, which becomes a very important one for many of the organizations as well as industries and so on. So this is one of the areas where if it is properly managed, it will reduce the cost as well as provide the best efficient way of maintaining, managing the resources available, including space, or also locating and using the resources in a most effective way. As you can see here, it can be a building, a complete three-dimensional picture, which will help you to understand where and what the objects are available, or the building structures can be understood more effectively. And also it can be connected to the entire globe from a very local information to the global information. That is the important part of this. As you can see, there is a large scale difference from very the minute data to a very mega level information which comes under globe. So that we are able to connect from local to a global phenomenon. GST helps you to provide actually. Okay, this is actually a slide. One after the other it should have come. It doesn't matter. In fact, actually, if you see on the top, you have got a spreadsheet. This spreadsheet provides you just a data about all the volcanoes available in the global scenario. But then, if you look at the data, you will not be able to make anything out of it. But then we have a map which tells you that where are these plates, the geological plates present. And as you can see here, the marks which are shown in red are those locations where we find the volcanoes presence. That means the positioning of the volcanoes are very much relevant to how the geological plates are present in our Earth's surface. So this gives you a visualization of a particular pattern from the data can be understood. But with all this, particularly for the academia as in particular, what does it mean for geotechnologies? Today, as what we are seeing from the US Bureau of Labor Statistics, they give you a very interesting study that total geospatial technology industry has now a very large demand in US as well as many developing countries. You can see there are about 79,000, which if you take it as 100%, the rest of the departments go in a very lower scale. That means this is a technology where all these are getting culminated, or all this information are flown into that, so that the total geospatial technology becomes a front runner now in all the job requirements as well as the demand of the country's requirements as well. And geospatial technology today, we have already, as we know, Digital India framework. It fits very well because it also answers to many questions like what, how and what way we can do smart cities. As you know, many of you would have read about the already we have got smart cities. The list of smart cities have been also identified. Then we also go for automobiles. These days, many GPS run equipments are there available with the new vehicles. Then we have got Internet of Things. Then defense surveillance is another important area where the geospatial technology can play a very important role. And we also have disaster risk management. This is ultimately a requirement when there is a natural disaster happens, how we can manage and monitor and provide the services to the people very quickly when they are badly needing it. I'm sure with all this introduction, what I have shown, you would be excited to know what is this geospatial technology. So I certainly welcome you to this wonderful world of geospatial technology. As a normal quest of human is always there, where? This is a question always asked. Almost 80% of our human decisions involve by a question asking where. Like the geospatial technology is a means to answer the geographic based questions like where to build homes. I think this is some of the real estate applications where the geospatial, in fact, the Google Earth and other web services are very strongly utilized today in the commercial applications. We are also looking for where to eat, where to go for the nearest hospital for any services, where are the occurrences of natural disasters, crime and security risks, as well as where are the assets to be protected. And there are questions are many. So all these are, as almost as you can see, they are all location based decisions to be taken up. So the geospatial technology by definition is a technology relating to collection and processing of data associated with location or region. This geospatial technology, as I already showed in the geospatial convergence, it's a group of technologies. It's not a single technology by itself. It's a technology of technologies. So we have very basic technologies involved in that are remote sensing, GPS, as well as GIS system. So these three are the primary components of geospatial technology. Coming to remote sensing, the remote sensing itself is a multi-concept. It is got different platforms, different altitudes, at different heights. That means we have got multi-stage collection of data for the same target, and we can also collect at different dates and times. That means multi-temporal. For example, are important, particularly when you want to know the change in direction. Like suppose pre floods and post floods, how much is the disasters or how much area is being affected by the floods can be monitored only through change detection analysis, for which you require a date, different dates of products for you to analyze. Then we also have different sensors. That means not one sensor will provide you all information that we look for. We have multiple sensors requirements, and then that also adds to the applications. In a way we can confidently use the data for the end applications. Then we have different spectral bands in multispectral. As you know, the ground signatures change. They have a spectral signature. Each object has got its own spectral signature. Then the multispectral is the only way, like a signature, we are able to separate the objects in a better way using multi-band data. And overall, as you can see here, there are also many platforms at which we can collect the data. We have got space-bound sensors, which are operating typically 600 to 1000 when it is polar sats. And when you are going to geostationary, it is going up to 36,000 kilometers. Then we have airborne sensors, which are mostly used like for mapping applications, as well as at the moment of disaster, any location-based immediate attention to be given. It is the aircraft which is coming to fore, and that also we have got at two different levels we can fly. And now they have got very ultra light aeroplanes, just like drones, which are becoming more and more popular. Then we also have ground measurements, which are very close range remote sensing, 1 to 5 meter. They are more used for validation applications part of it. So as you can see here, the remote sensing by itself is a multi concept. That means you have got multiple platforms, multiple dates of analysis, multiple sensors are to be collected. Even in a sensor, there can be multiple spectral bands. So this complexity is high, but then this is how the information is drawn from the ground for us to do the assessment of the ground reality. So as already said to you, that remote sensing uses photography, radar, sonar, as well as infrared and other technologies to record information about the Earth. This is the ultimate information that we look for. As said already, remote sensing can collect the data, but not necessarily only from the space platform. Nowadays, we have drones and other airborne systems which are becoming more popular. And it is more and more. Earlier days, we have been recording it in the media as well as other approaches, photographic papers. But now all information are going more into digital and transmitted in an electronic way. And they also, other important applications from human being is that we are able to acquire the data at bands which are invisible to us. That means beyond our perception, we are able to collect the data from the remote sensing platform. and all data sets are needed to be georeferenced for the applications so that the features are identical in all different scales of information. That remote sensing, when you talk about, we can also do it in two different levels. That is high resolution. That means it is best for observing at human scale. As the right image shows here, it is like Barack Obama, the president of USA inaugural address. When it is done in US, you can see here the number of people who have been collected at both ends of the monument can be very easily seen. So this is like an event monitoring at a location. How the event has been progressing can also be recorded and analyzed. And naturally, because we are going for a very target application, that means the area of collection becomes important, but the best information possible from space platform is available here. The next one is, of course, the vehicle flow analysis. It's again at a human scale and at a time when we wanted to study what is the traffic flow across a toll gate. For example, this is a New Delhi toll gate, which has been shown here in this picture. You can see how the vehicles are accumulated at a particular time, particularly in the time of vacation. You can see how the roads are getting blocked. So it helps us to plan and do remedial solutions for such a highly traffic prone issues. So this is what we say as the high resolution data, where the application should be very clear. That means we are looking for a specific location based information, but with a very high information content. But at the same time, the area collection is also slightly restricted. Now we will see the next one at a low resolution what we can do. Look at this picture compared to the previous one. There is a huge area which had been collected. The basic idea is to see whether the impact of climate change on in the polar ice. As you can see, some of these ice, big chunk of ice pieces are getting broken out from the large shelf of ice, which is an indicator for which is an indicator for the climate change and global warming elements. But then to study this, we also need to collect systematically, regularly, sometimes even daily basis. Data sets are required to study and monitor the impact of this in this area. And this is another important application, like where the regional information is very critical. You can see here how the volcano is progressing over a period of time and what direction the polluted air is, the polluted plume is going to pollute the atmosphere there, and that becomes a very critical one for alert mechanism. So again, the regional specific applications do not require very fine resolution, but at the same time, it can provide you the information that we look for. So the remote sensing, really, if you see from these two point of view, the fitness for purpose, that means what is the targeted application, whether we are meeting or not. That is the crucial part of the information which we can gather from remote sensing platforms. And it can also become multispectral. That means we have got many more bands available, providing you an applications like, for example, when you compare between the lower image and the upper image, almost of the same area, the red ones are basically the vegetation. The thematic scientists know about that. So this is very easily identifiable, and even the textures of the color are more easily to interpretable for the human being. So that is why the multispectral data is becoming very popular. In fact, many of you will be knowing that Carto 2C had been launched, and the products also been well received. One of these the sensors is a multispectral data, which is going to provide the very highest resolution available today for us. Then we also have panchromatic data, which is again providing a very excellent data, but it gives you again a very specific target oriented applications. But then one of the issues are that how to interpret this data. Coming to the remote sensing further, that what are the characteristics of the image, that is very critical when we are talking about the remote sensing data. Why I am trying to go a little more detail on this remote sensing is this is one of the fundamental data elements based on which this geospatial technology today is being fully exploited. So let us know a little bit on that, because this is an introductory chapter. I'm sure many other lectures will give you more detail about the geospatial and how these data sets can be exploited. So here what we look for is spatial resolution and scale, contrast, sharpness, wave bands, and different formats. As you can see here, the 8-bit data at the bottom image looks slightly blurred, and the edges are not seen very clearly, whereas when you go to the 11-bit, you are able to make out even objects in the under the shadows can be seen. Little bit expansion I'm trying to give you here. One of the very fundamental parameters in remote sensing is a radiometric resolution. If you look at this photograph shown here, the 1-bit data, you are not able to see any of this, if any features present here. Then when you go to this 2-bit per pixel, you start seeing some sort of blobs, yeah, block features. But going to the 3-bit per pixel, you see some structure of like a cross you are able to see, and 4 bits per pixel show you some sort of a structure of an aircraft. So this is how the information slowly getting added. So and as you can see from 5 to 8, how the information has been collected in a way we are able to interpret much better, even either a human being or by machine. So the number of bits per pixel is one of the very important components for learning the information from the satellite data, or even for that matter any image data for applications of GIS technology. And here we are showing the variety of the sensors available today in the multispectral domain. We have got IRS 360 meter resolution available, then we have got 188 meter, then 76 meter, and going to the last 36 meter resolution. They are, for example, the regional applications which we are talking about, because they collect a very large area and provide you the first-hand information about what is there in that particular area of study. Then going down to further detail, as you can see here at the bottom row, you have got starting from the left, you have got 23-meter resolution sensor data. You can see here some features are coming out very well. And we go down to next again panchromatic 5-meter. You are able to see the features much more clearly, because this is actually the Delhi Rajpath Road. You can see here again 1-meter data showing you much more detailed information available from the satellite platform. Well, we have a very huge asset as far as the information availability from the ISRO's platforms. We have got geostationary satellites which are providing you at a very high resolution, providing you excellent data and continuous monitoring of weather as well as resources applications. Then we also have a large number of uh, polar satellites, various applications, right from resources monitoring to ocean applications as well as mapping applications and so on. So it gives you an enormous potential of usage of satellite data as well as aerial data for applications of natural resources monitoring and management. And Indian's Earth observation program has got very important components. We have got a land and water mission, which covers generally all the information about the land and resources applications. Then we have got very high resolution data, primarily meant for mapping part of it, mapping applications and cartographic applications. Then we have got ocean sensors, which are specific for weather forecasting as well as for knowing the bio optical information like potential fishery zones where the fish catch can be much optimally selected, and also we have got weather and climate modeling sensors also available. So we have got capability to provide an image of satellite of any region, right from 1 kilometer to a sensor up to less than a meter. We are in a position to provide this information. Then the scale is another important part, because it is the scale by which we are able to visualize the data from global to the finest resolution. As you can see here, 1:50,000 to 50,000 scale, because these scales are the ones which will go along with the map and other information available from other resources like Survey of India and other mapping solutions. As you can see here at 1:10K, 10,000 scale, you have to see features much more sharply, much more ability to apply and visually analyze the data. This is another interesting example which is shown here, and this is shown in the platform Bhuvan, where you will be able to work and easily understand many of the features as well as use it for various spatial analysis purpose. I think this I have already covered. Let's skip it. Coming to GPS, the Global Positioning System, but a well-known system like GNSS of US, there are many satellites available, 24 to 32 satellites, which are orbiting at about 11,000 nautical miles, providing you continuous connectivity to the ground. In fact, these satellites have got very accurate atomic clocks on board, which provide you and send you the radio signals towards the Earth in a very precise manner, and then these radio signals are picked up by the GPS receivers. This is how the positioning system is working very well. And you can see here how GPS is a system we need to understand that there are three basic components for GPS. We have got GPS receivers, then satellite constellation, not one satellite which will provide you the accurate information. We need a group of satellites. In fact, next slide will show you how many minimum would be important for more accurate information, and also supported by ground control stations. This is again important for differential GPS analysis for better accuracy. Yeah, as I told you, this is how the GPS can be used for locating an object. There are four constellation you can see here. Four satellites are locating or looking at a particular point on the Earth, which will provide you the location by what is known as triangle. We'll position by knowing its positions of these four satellites at this location. We are in a position to know where we are with reference to the general reference frame. Then coming to geographic information system, many of you would be aware, but for some of you, I just give you this introduction that JS term, basically geographic means, yes, it's a geography, but then it really means that it's going to deal about location, interactions, and distribution of people and places and so on. That means all about the location we are going to get from the geographic point of view, and how they are related, how they are connected, all will be able to study from this particular point. Then information, again it stands the same way that the information usually means a database. It is a collection of all information about air photos, data, spreadsheets information, GPS units, satellite images and so on, all are collected, and then this information all will get pulled into a particular system which we are going to see next. That means this is a system where we are going to have GIS operator, the computer, as well as data, as well as software working together to solve a particular problem. That means from geospatial data, geographic data, where the location information is available, to the people and other information about the particular location, as well as the interactions, all are brought into the system to make a more meaningful synergy as well as the interaction part of these elements. Like as you can see here in the next slide, it provides you the synergy of different types of geospatial data, and sometimes this is also called GIS funnel. That means you pour in all the data what you have in hand, and it tries to do a mechanism modeling by which we are able to do to work out and try to bring out the spatial relations as well as patterns between them available. And it is also simplifies the confirmation of observation from various platforms. And you can see here the GIS database can also get a lot of information. Generally for the Earth observation, we are using hard copy maps. We are also using ALTA, airborne laser terrain mapper. We have got remote sensing platform, photogrammetry, GPS, as well as total station. So these are all where we are pulling the data in one platform and trying to analyze and provide the spatial relationship. So ultimately, this is a spatial database management system. That means we get in all the information right from the subsurface to the upper surface of the earth, where you can have the map details about hydrology, topography, land use, utilities, soil, street maps, districts, parcels, all can be combined, and you make into a database to store and query the data related to the objects in space, and including points, lines, and polygons. So this is one of the reference data which is going to be useful and provide multi-user applications also for providing this information database. Now coming to this GST, geospatial technology, when you put things all together, this is a simplified flow what you will get. One is the data acquire. That means this is the first level information one looks for. So you have got imaging platform, because it is a continuous data upgradation. It's not one static image. That means you have to collect large number of satellites and data sets for continuous monitoring of the system. So collection of data from satellite platform, UAV, and many other what we have discussed earlier, like aircraft means, or even the ground-based data. Everything would be of very useful. Then we have got GPS satellites providing the location information. When these data sets are all connected, we get the location information as well as remote sensing data combinedly to make into a GIS analysis workhorse. So once this GIS analysis part is completed, the end objective or the user's requirements are how we can generate maps, how we can document the information collected and evidence, as well as how we can use this data for immediate applications in hand. So this is the overall platform how the GST can be implemented in the applications one demands for. Visualization is one very much part and parcel of this, because this is, as if you recall, the human machine interaction finally ends up here. That means we need to provide the perspective view of the objects, so that it's as if we are flying over the object trying to know what it is. So it also helps us, helps the human beings to study and bring out the modeling of the scene. Like what you can see at the bottom image, you can see how the trees are planted, how and where are the buildings, and how what directions they are planted, all will be available. And it's also very important to know how safe these buildings are from the ambience disaster prone areas like. Then we have the 3D visualization, very important for surface modeling as well as analysis. There are many images are shown here. You can see here the contour maps over the image, which will help you to know where are the concentric heights and variations are there. And you can see another image which is at the subsurface level, where are the drainage and the other power lines are there at the bottom of the road. All can be studied from this. So 3D visualization is a very much important component of geospatial technology. And in fact, this is where the geospatial technology is a very important tool for applications. And other applications which I'm trying to show here is the 3D city models. This is, as you know, now we are going for more and more smart city requirements. That means that each area, each region, and each buildings need to be self-sufficient. That is the primary objective of this, and having all resources manageable at their own locations. And for this, we also need to do lot simulation to see that the actor is really met. Of course, here it's a video. It is somehow not come here clearly. I can see here a building on using 3D GIS based. We'll be able to simulate the solar position at a given time, which will provide you or which will allow you to know how and how much solar power can be drawn for natural applications like lighting and so on. And the bottom one, you can see here another interesting application. As you know, these days, because of heavy traffic, how the noise is building up, whether it is going beyond the limit of a normal scenario, and whether it is to be alarmed, whether whether we are risking the children and other people who are out for school with the high dB. All this can be studied with the help of traffic noise modeling. This another important application is the Indian Bioresource Information Network. This is very critical because we need to know more about how the data bioresources are available, and we have to decentralize because there are many departments work and they need to be brought into one platform so that they share the information and update the information periodically from the resources first made, like a biodiversity information system. So that is what is getting upgraded with the various departments jointly working on that. This is again a geospatial services which are provided for different departments, like already it is mentioned here, the biodiversity and check the artery Bangalore. There are medicinal plants centers. There are many such Himalayan plants, Palampur. Many departments work on this to provide a periodic upgradation of the information for various elements of this biodiversity information sources. Then this is the traffic monitoring with the wireless system. That means this is another applications. Though it is not fully implemented, this is one of the important technology which will be very useful for the planning applications. So you can keep the sensors buried on the roads or some surface level. You will be able to monitor the vehicle flow and then understand what is the way the traffic information system can be built for a given road of Bhuvan has already told in the introduction that we have got the Geo portal equivalent to Bhuvan, equivalent to Google, and it's beyond that. In fact, Bhuvan is now one of the best sources for information available for Indian applications, providing all types of data and also data for many researchers to explore many new applications as well. So we have got Bhuvan 2D and 3D, allowing you visualization and place name search, overlays, and all applications. Then we have got also open EO data archive. As I told you, these data sets are available. After some time, the products are available for free downloads. Then there are also many thematic services. That means the research which had been carried out by ISRO and allied many departments which are jointly working with ISRO, we are using this data and sharing this information also through web services. Then disaster services is one of the very important tools and the services provided by Bhuvan for better decision making at local level when there is a disaster happen. Then we have many projects which are all provided for visualization as well as sharing the geospatial data for many applications of importance. Then health GIS, another very important tool because it's a part of the digital India requirements. We have got e-health care. Then, as you know, with health, we with all these data sets available about a particular disease at various locations in the urban map, we will be able to know what would be the cause for a particular disease more prone in a specific area. So this is a very important application which is really going to be a very important future requirements for our monitoring the health in a geospatial manner. That crowdsourcing, this is a very important one. As on the left it is shown here, the crowdsourcing workflow goes with, first of all, a mobile device in hand, and we go for data collection, then geotag the data, then data transmission is from the mobile to the web page, web portal services to be done, then data is stored, quality is checked, and visualization on the web is also made possible, and ultimately the data is made to use with the help of various tools available here. So the crowdsourcing becomes a very important way where the people, the citizens, become voluntary sensors to provide all information locally available, because in every time it is not only the satellite data and airborne data which should be having the first hand information, because the location, as we started with, the whole GST is mainly an information we are building for location based services. The locations information, instantaneous information about the locations are best drawn from the public. And that is where we call it as citizens as voluntary census, providing very important timely information for the web services. I'll give you some examples where this kind of services had really made a big difference in monitoring. For example, one of these applications is mapping the neighborhood in Uttarakhand. When we had a big disaster uh, during this Kedarnath floods, there are teams worked with institutions like we have a team from IIRS, National Remote Sensing Center, Survey of India, the DST, as well as universities, Garwal and Kumaon universities, as well as Wadia Institute of Himalayan Geology. All combinedly we worked and tried to do this mapping. First of all, there was a capacity building was done as to how to collect the data by the students from the local region. And this is a very important start of this particular program. As you can see here, when they collected the data within a very short period of time, about 19,000 points have been collected, and each point, when you click it, it will show you what is the real scenario, where the people are stranded, what is the condition of the location, particularly, for example, road breakup, all that well nicely mapped. And with the tagging, it becomes very easy for any national disaster management authority to work on it and provide the very quick solution for the people who are looking for immediate support. This is GIS based smart city planning, where the smart city needs to be combined with the governance. Particularly, we have to do smart governance for smart education, healthcare, as well as building. I already told you. Then mobility, as well as infrastructure, then technology, as well as smart energy. All combined provide finally the GIS platform for developing and achieving smart cities. This is one of the biggest projects which are going on, and I'm sure we'll be in a position to achieve this with the technology growing more and more researchers who would be joining, because the smart city is also very much is location based and even region based. What is applicable for coastal city will not be applicable to one in the desertic area or in other hilly terrain. So it is a very much location and terrain based important changes would be there for city planning. So that needs to be accounted for it. And GIS for farming is another important activity which has been taken by Mahanabali's National Crop Forecast Center. As you can see, where although the forecasting has been happening regularly by satellite platform, we are also taking the help of the farmers, because who are the final users of this data. With the mobile technology, people have been trained, and these data sets are now pumped into Bhuvan, wherein we can see at each location what is the growth status of the crops, as well as study the behavior or any stress is there on these crops. So this helps you. The field data collection together with the satellite data provides you a platform for crop monitoring and making a quick decisions what needs to be done if there is a stress on the crop. Then this is another important application, like the crime management and mapping, because this is another very critical one which is very important, particularly when you are going for more and more high resolution information, and when we go for more and more challenges from various organizations. We need to work on the how to tackle the crimes, how to find out how geospatial technology can be used to uh, find out the pattern of the crimes as well as the forecasting. See, this is a very important application, that as all the crimes as or specific activities are happening, then they become hotspots of the analysis, and we are able to find out a profile, buffering and other applications, so that we are in a position to know how to manage and even help in operations, like how to do patrol routing, as well as response times, all can be done in a very effective way. Then this is a hydrological modeling. Of course, this is from a very finest resolution of what we require for crime as well as other applications. Here we require slightly at a lower resolution. Now, even that is a very high resolution as far as the modeling people are concerned. We are now having a very high resolution data in Bhuvan, which is also provided from Indian Institute of Remote Sensing. We have a very large number of models information have been put for generating a forecasting information of all types of uh, surface parameters which are required for various modeling, including the weather and the Indian monsoon region applications. So this is a very important applications which are for many applications as well as modeling. This data is very vital, and this is being provided. Now there are about 36 number of layers available in Bhuvan for with very high resolution data. This is another application which is very evident when we use the geospatial technology for an applications like Swachh Bharat Abhiyan. We made a very experimental one exercise wherein we have initiated along with the 12 government organizations in Dehradun. In fact, you can see here how the satellite data or the map has been used, and we have used the buffer analysis using GIS technology. This is mainly to see where are these institutions are located and where are those hotspots where the dustbins are to be removed, where the garbage is maximum, and what number of people are required. All these patterns have been studied, and in a very coordinated way these exercises were carried out. In about just 2 hours, a very huge collection of and removal of the garbage has happened, which was well appreciated by the local management. So what we are trying to say is, with geospatial technology for a very focused applications like Swachh Bharat, we will be able to make a very strong impact and make all things in a very shorter, with a very efficient way. We will be able to achieve the end goal. Then we have many other diverse applications of space-based applications. We have got agriculture where we need to do the product estimation. Then in fisheries, we have got the potential fishing zone where the fish has to be likely to be captured, so that we can minimize the fishermen venturing into deep sea, as well as fuel cost can be reduced. Then we can also monitor the irrigation and infrastructure, drinking water projects, or another important project which had been taken along with the government as well as ISRO together solve this problem. Then we have got natural resources census were also conducted with in a project mode with the various departments. This is another set of applications. We have got applications in forestry. We have got snow and glacier applications. We have got national urban information system wherein we are able to provide the urban planning and infrastructure development for the benefit of development of a system for different applications, particularly for town planning purposes. Then we have got decentralized planning for panchayats, as well as weather and climate modeling is also another important applications from space technology. As we have told in the introduction, we have already with this exposure and applications understood very well by various ministries as well as being utilized. So we have now gone into a very large number of projects with the various departments, and the progress has been very high, and it has been well appreciated. I'm sure very shortly all the projects will be completed, and we will be in a good position to show how the geospatial technology can be of great help for many of these important national projects. Well, any field will have challenges, and that is why this field is very important, and it makes it more interesting as well. The challenges are, as I already told you, we have got a variety of data sources. That means we must be knowing how to bring the synergy between various platform data. There are challenges in finding out, and even the redundancy of the data is again another issue. How you can remove the redundancy and make the best out of all the information available. Then automated processing. See, today the decisions are, as we have said earlier, we are looking for a turnkey solution. That means just the data flows in and you get a decision to be coming out. That all calls for an automated processing mechanism. So this is still a long research for academia who are all listening to this particular course. There is a huge research potential in this area. Similarly, the information fusion. We have got, as I told you, we have got multiple resources, satellite data, airborne data, ground data available. How to fuse this data seamlessly. That is very important for these applications. Then we also have multi-information from the various sources, including the, how interpret with how a human being can easily interpret the information. It is to be brought to this extent of analysis. Then smart databases, we are using the content-based image retrieval systems, intelligence agencies, and so on, where all by which we will be able to extract the data with very minimum data available so that we are able to use it. Then human computer intervention is another very challenging task, particularly visualization is one of the very computationally intensive program, but that is what the challenge is. Then of course analysis as well as knowledge recovery, that is very important from this. So as we go here from data to information knowledge, the maybe next slide will show you how we are going to improve that part. Yeah, as it is shown here, when you have multi-platform, multi-parametric, and spatial, high temporal, remote sensing in situ data, we may have in hundreds or thousands of petabytes data in hand. But when you come down to working with others, other data sets, doing the fusion, other information, it comes to terabytes. Then further processing with the location information, other applications, this data can further be reduced. The knowledge from the data to information to knowledge is how we are going to get it here. And sometimes the megabytes may be just maybe the knowledge that we are looking for to really act upon whether there is a flood, how much how much is the disaster happened, and so on. They are all very minimal information, but that is the knowledge for which we need very huge number of data, huge amount of data, like in terms of petabytes and more. So ultimately, the user wants the simple interface and fitness for purpose. This is the crucial part of the whole remote sensing as well as JS platform applications, where we must know the end user requirements and tailor down the requirements so fast and so automated way so that we are in a position to provide the needed people in time and with the best possible means and improve the accuracy and quality of the data. So this is a major challenge in the geospatial technology applications. And with this, I think I'm concluding my talk. Thank you very much for your attention.